I had a really interesting chat today with Pavan, basically talking about the quantum teleportation, and we're trying to explain these in a more intuitive way without actually taking a look at the state vectors and just visually and trying to understand these, using quirk, even like using. And it's like I kind of again feel like I just intuitively I understand it's intuitively easy to explain, or it should be easy to explain. But it's just like the explanation, if you try to put displays here and there, it just becomes a bit cumbersome to try to explain what's going on in between, right? Like, yeah, I get it. There's, entanglement between these, the qubit from Alice and Bob, and then Alice entangles also the message qubit, and then you apply the Hadamard, and then you kind of do the pause measurements corrections, and because that's what you're basically trying to achieve with these is kind of create two different types of sort of two different types of superposition or entangled state, and so based on the measurements you're going to have here, you can just correct the actual amplitude in both dimensions. Now it just doesn't feel like it just feels empty, like empty words, and I just thought like it as this is entanglement, this is really a great chance for me to use this as an example for doing these. So basically doing it maybe here by hand before even moving forward, seeing how would this look like, and also trying to see if I can gain some insights in terms of how the heck am I gonna keep the probabilities once I split nodes, because this is something that I haven't figured out. And I thought the idea here with the system edge maybe it doesn't make that much sense really at the end of the day. I should just have an edge per qubit, and then because it's going to be easier to access the qubit nodes, and then maybe the labels don't have to have the qubit in the label. They can just have the edge they belong to make them a bit different, or whatever random thing in there to make them a little bit different. That's because if they are the same, the system considers them the same node, and that's just something that for the prototype I don't really care. I really don't want to deal with these. But maybe instead of, because then it would mean I need to refactor that again. Let's just see if we can. Let's take these. Okay. So let's take these and let's see if we can basically simulate by hand step by step what the circuit is doing, right? So we're gonna have teleportation. Let's just call it like TP. So the easiest will be if I just also keep these here. And what we want to do is we want to have the the initial state would be these, right? And again, we're not doing the whole thing here. We're doing, so let's just say Q0. And again, so we have Q0, this would be Q1, and why is this lagging again so much? Q2, So I have 3 qubits. So what I'm basically doing is I'm just saying, so for qubit 0 encode these, okay? So bam. Now I'm gonna add a comma here and another comma here, and then just have these like that, and then draw it. And so this is gonna be an edge for Q1, edge for Q2, and then can we just encode state like I think I'll just say, you know, Q0 step 1. I just like Q1 step 1, Q2 step 1. And so this is Q0, this is Q1, this is Q2. Okay, so this is the way we're gonna draw it. Okay, so what does this look like? Well, what about we draw TP? So we should just have 3 qubits exactly. Now I'm gonna just do it by hand in the sense that so this is TP S1 actually. Okay, so I'm gonna probably, what I'll do is I'll just print like maybe, I don't know how many steps do I need, but like step 3, step 4. So I'm just gonna hard code those because I know how I want them to look like, right? So I know that I want these to be so this would be step 2. This is just bureaucracy right now. Step 3, step 3, step 3, step 4, step 4, step 4. Okay, cool. So what do we want to have now? So the first operation, right? So the first is just, this is just initial state, right? Then we're going to go ahead and just keep like, you know, I will say the message is Hadamard gate, right? So the plus state. So I'm just going to go ahead and kind of, you know, this is basically entangling. So this is basically a C, not like a Hadamard on qubit 1, followed by a CX between qubits 1, 2, and followed by a Hadamard on qubit 0. That's how we're going to do this. So I guess the states that we have after these, so that's how this thing should look like best. Initial state. So they'll be basically, what will they be? So let's go step by step. Let's make a simple version of these. So let's get rid of these. 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 And let's put a Hadamard in here. We don't care about these. We don't care about these. We don't care about these. And all I care is about the amplitudes of, to be honest, it's impossible to know, isn't it? Now here I know that I want to create these two this thing, right? So I know it's a CX. I know that we want to have not only these edges, right? So okay, so Q0, it's basically in the state, you know, 1 divided by square root of 2. Like we know that we're in this state for Q because we have applied the Hadamard, and for these, we know that we are in 2 separate branches, right? One where so the branch 0, 0 and the branch 1, 1. So So actually we will have multiple nodes in here. This will have been split into 2 nodes, right? So this will have been split into 2 nodes. So this would be node 0. I think it's really helpful to do this by hand because it really, so node 0, node 1, right? So we want to have, we're going to have 2 nodes in here, and we're going to have also 2 nodes in here. Node 0, node 1. I'm really just gonna, what I'm trying to do is just hard code how the hypergraph should look like, okay? Yeah. So basically the node 1 is like a 0. So this is this, and this should be like basically the opposite, right? I think that's how it should look like. And so we need to encode this state in here. We need to encode 2 states in here. So node 1, that will become tedious. Node 0, step 2, step 2. And Pam. By the way, I recommend you subscribe to Pavan's newsletter if I haven't said that already. So there's some cool stuff in here. Some quantum stuff as well. Cool. So what do we have now? So we have Q2, so we have, well, it's definitely Q2 and 0, and there's Q2 and 1. And now we have 2 more edges, right? I wonder if this is gonna work. If I just add like, so edge 0, right, will be 1, and basically edge 1, right? So this would be kind of the mixture of encoding. So this would encode this state and this state. I don't know if this is going to work out, okay? If this is going to represent it the way I want. On this state. And this is going to encode the 1, 1. One, one. Let's see. We don't care about these. We want to just print the. Oh. Why does it like? I thought it would. I thought it would just. Okay, so it draws these. So what does these do? So we have qubit 0. It's separately, and then qubit. Okay, so. Oh gosh. I think I cannot read the edges. Edge 0 and edge 1 seem to be these, which connect. Something is wrong. So something is wrong in terms of the qubit 1 encodes Q1 and 0 and Q1 and 1. Qubit 2 encodes or holds Q2 and 0, Q2 and 1, and these nodes. Oh, sorry, I used the wrong labels in here, and so of course I get confused. There you go. So what you have is, no, but that's wrong as well. Okay, so it's not doing what I want. I think I think that, but that's good because at least I know that it's not working the way that I would like it to work in terms of I cannot hold these in edges. If I hold these in edges, it's not showing what I want. So if I comment these, right? And this is still called like system. So I should just remove them from the system edge. Because they must be in an edge. That's the problem. Like if I would add, maybe. Maybe I should really. Maybe I should really encode these things here. And then I would still, because then they would get like a single ID, right? Because that's not correct. So that's, what is this connecting? So that's in superposition, cool. And this is connecting. I mean, this is correct. Qubit 1, node 0 with qubit 2, node 0. There's a mistake. Qubit 1, node 1. Yeah. So first we have a system. So we have one edge that's just a system, and then I don't like that because it means that this needs to somehow stay floating in this fake edge, which is system. Well, but it's maybe a way to say, okay, those qubits are not entangled; they're still part of the system edge. Because if I add these two, I'm essentially that's not what it's supposed to do. Oh wait, it works. Oh no, of course it works, but because I have removed them from the system. No, that is Q0. Sorry. No, I haven't removed it from the system. That is correct. This is correct. Qubit 0 stays here. Then we have the edge qubit 2. So those are two nodes of qubit 2. And then the edge qubit 1, which are... Yeah, no, that's correct. Okay, those things still stay like that. That makes sense. You're just connecting two qubits like that. Okay, maybe that still makes sense to keep those like... I don't know. I don't know. One approach would be we keep nodes like that. Another approach would be we keep one node that's called system that holds the qubits which are not entangled, and we just remove this from there. But then we have to care about like putting it back to system, which kind of bothers a bit. So I might just keep that. We'll just maybe have to have a custom rendering so we don't maybe render the qubit edges. Okay, but that works. That's gonna be time consuming. So the 0 and the 0 are connected, and the 1 and 1 are connected. Yeah, I shouldn't care about these labels, to be honest. It's just too much work. But what's next? Next comes the this thing here. So comes the control node here between 0 and 1. So what this would mean is, let's zoom out a little bit. So what this would mean is that we have the system, right? And for TSP, no, TPS3, right? And so we have this system, but now what we want to do is we want to have these connected to this edge. So these will be now connected to qubit. I'm dense today. Q1 in a way that if it's 0, right? So we now need to split these. So this is not anymore like that. So this is now two nodes, right? So we have this is painful to do by hand. This is really painful to do by hand. So now we have Q0, node 0, Q0, node 1, 1, 0, 0, and 1. The problem is that how can I remember that I'm splitting from a 50-50 probability? That's the problem, right? So I would need to keep that somewhere. I feel like I would need to do that. But basically now what we have is, you know, Q0, node 0. Yeah, I think I can ignore the S's in here. So Q0 and 0, and this actually should have these, and we now have two more edges. Edge 3, I guess it is, and edge 4. Which basically what they do is they connect this guy over here with So you do nothing. So you want to connect. Now the question is, you want to connect to, how do you do this? Okay, so does this connect to, does this connect to all the elements that used to be in E0? Or it just connects to Q1 and 0 S2? I think it just connects to this one. I think it just connects to this one, right? So it connects to Q2. God, I hate this. I have to remove these S's. So it connects to Q1 and 0, right? Well, it connects to both. No. No. Yeah. Because it connects to the whole Q1 layer. That's the point. It takes all the nodes from the Q1 layer. It duplicates them. So it actually... That's tricky, man. That's tricky. So I should duplicate those. Not only that, because I'm duplicating elements that belong into two edges, I gotta duplicate those full edges. Like they are gotta carry the whole thing. Gosh. So I gotta duplicate those. I'll call it like node 3 and node 4. I gotta duplicate those. Crazy. Node 3, node 4. And now I gotta duplicate, like, I'm gonna create like the proper edges for those as well. So there's just basically, so E01 and E11, they'll actually be, you know, node 3 with node 3 and node 4 with node 4. God. Exactly. And yeah. And so, and these is gonna connect with basically the first half of the first half of the original nodes, right? And the other one is the last edge is going to connect this new node, which is in state, this new node, which is in state, in state 1 with okay, with, and now this is the trick. So now I gotta negate these ones. I gotta apply the control knot. I gotta apply this control knot in here, right? But that's the last step, actually, I think, because I'm not gonna do the hard mode. I just want to see what I get with these, because that should give me the structure that I want to show with these model, right? It should give me the structure to tell you what it is, how is the entanglement growing, and in this teleportation case, what does this, how can you see the teleportation working like that? Like you'll see that you're setting it up in a way that like it does the teleportation, but I gotta get it right. So, but I think we're not gonna need the step 4. That's about that's all we need is step 3. All we need is step 3. But I gotta create 2 more nodes, which are basically like you know, like an X of these and an X of that. So an X of these and an X of that. So Q1 and 0 and Q1 and 1, they're gonna have basically their negated counterparts, which are just gonna be, well, obviously their negated counterparts. Wow, I hope this works. Oh crap, that's gonna be difficult to see. Okay, how can I draw this in a more zoomed out way? So H and X draw. It's called Hypergraph Python. It was called Hyper. How was it called? Well, I have it in the code, you know. I have it in the code. HyperNetX. Stupid. No. I want to make that. I want to print that because it probably has some parameters in there. I might be doing something wrong. Let's read the docs. Why is it so slow? %15 CPU. God. Oh, come on. Let's go back to GitHub then. Because I should get, like, I should try to ignore. So the documentation is here. Draw. What am I using here? Drawing draw simply. I just want to get the function draw. Ah, there you go. No, 2-column draw. Layout hyper edges. Module contents. Just, why does it go to the end? With color true. With no counts, with edge counts. No radius. Ah. Oh god. What is E for and why is it disconnected? I fear. Oh, god. So Q0. Q0's got now two nodes. One is 0, and another one is 1, right? Yeah. It's wrong. We don't need to double Q2. There's nothing oh yeah, no, we need to double Q2 because we need to double the whole thing. So we need to double Q1. So we create basically the nodes 3 and 4 for Q1. Oh, okay, so I get it. I know, but yeah, they're the same like these ones, right? They're the same like these ones, exactly. Yeah, I think there's something wrong with these. So, man, this chair is just bad. So we encode these. Okay, wait a second. There's something wrong. So first of all, this is this. So, and then these edges stay as they are, but we clone them. And that is between Q1 and 3 and Q2 and 3 and Q2 and 3 is Q2 and 0 and this is Q1 and 4 and Q1 and 4 is Q1 and 1 and this is Q2 and 4 which is Q2 and 1. That is correct. And then we're creating two more edges between Q0 and 0, right? And basically Q1 and 1. Okay. So this is the thing. No, but that doesn't change anything. That doesn't change anything. These should be connected to the negated version of these. It's nothing to do. Oh, I know. Those should be negated as well. Actually, that's the mistake. Those should be like these. because otherwise we're creating extra labels. I think now I got it. Can't take that long. Okay, that looks a bit better. Let's see what we have. So we have... okay, so we have... what's the overlapping? That sucks. First of all, where's Q0? E4, Q1, Q0. So we have Q0. That is already not correct here. Oh, this is a mistake because this is Q0 and 1. Q1 and 3, Q1 and 4. Oh, I think that's about, I think that looks better, but it's still... what if I painted, maybe this is drawing rubber band, not rubber band, but like there's a column, right? There's a 2 column. Okay. What if I call, is it going to be clear? 2 column draw. Oh God. That is not what I meant. I thought there was the... no. Okay, that's just rubber band. Let's just use rubber band because that's gonna be it's messy. So the default is rubber band. Rubber band. Oh, come on. Jesus, the CPU usage on this is just nuts. Is this catching the right microphone? Like, I think so. I think so. I think that's catching the right microphone. Let me try one thing. I'll just mute it. Yeah, okay, that's correct. Okay, it printed it a bit better. So we have, what do we have here? Okay, so Q0, that's good. So Q0 is basically here. We have 2 qubits. One is in the 1 state, one is in the 0 state, and then they both connect to, okay, but there's a mistake here, I see already. So they both connect to Q1 to 2 separate qubits, right? So now I think these ones 2 here should be connected to these 2. I think that's the whole essence, because that's Q2, the green thing. So I think the mistake is Q1 and 3, and Q1 and 4. So E0 and E0, so these should connect. Okay, let's think about this. So this should connect the same. Problem is that these 2 guys, Q1 and 1, should be in here as well. I think Q1 and 3 for some reason Q1 I get it. They should be connected to the negated versions. That's the they should be connected to these ones. So I should use these, and that's the mistake. Yeah, I mean programmatically that's not going to be that complicated, but it's just tricky to get by hand. Oh God. So, but it looks a bit better, I think. So we have qubit 0. How does this look like on your side? You probably can't see. Qubit 0 that is split in here, and yeah, and that basically we have two edges, E4 and E3, that kind of connect to two different, you know, portions or subsets of Q1, right? Which in turn connect to two edges in here. It's actually really messy to see. So I don't know if this is gonna be an easy thing to visualize, to be honest. Doesn't this have any other nice visualization? No, it's inflate. Mm. How about we use a network X like graph layout algorithm on a hypergraph? The two-column model. Maybe now the two-column helps a bit more. Maybe actually that helps a bit more because I can then just say, wait a second, where was that? Here. Two-column. Okay, maybe that helps. Because what I'm trying to say is you have 4 nodes for Q1, 4 nodes for Q2, and 2 nodes for Q0, right? So let's see where we're now here. So we're at here, right? So we haven't applied these Hadamard yet in Q0. Once we do these, oh gosh, that is just hell. Because once we do these, it means we gotta carry. So what we're gonna do is apply a Hadamard here. Okay, no, that's not that bad. That would just put these. Okay, so that would just it would just put these state into superposition and this state into superposition. That wouldn't split anything. So that doesn't make a difference. It doesn't make a difference. Does it? I don't know. I really don't know. Shouldn't I just... No, it shouldn't matter. It shouldn't matter, really. What it does is it just applies it here, so effectively... How do I control 1 and how do I 0? Okay, so if I want to do this well, then I should do this well. So then what I should just do here is... kind of have node 3, node 4. So that should be square root of 2. And the same is below, but with a minus, right? So they should really be like... But all that changes is the two states up there, that they now become... I can take that one. Well, because it's NP. Exactly. What? Yeah, well, if I didn't forget it here, it will be good as well. Yeah. Oh. I think I should just call these guys like this. And then... because they're connected, it just changes the content of the node, but I want to keep the connections. See, the problem is that, yeah, exactly, that's correct. So now you have these things in here, right? So okay, I'll correct myself. This is actually... So this is actually the Hadamard. Yeah. No, 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 no. This doesn't have this one. Okay, it doesn't have this Hadamard, exactly. It has the first Hadamard in the control node. I just forgot to do it this way. Okay, cool. But that's correct. So now what the whole story here is, and you could probably do some tracing on the lines, right? But the whole story here is that you want to say that if you measure, so if you apply a Hadamard now, right? And this is just a hard-coded example, right? But if you apply a Hadamard now, well, that state would be a 1 and that would be a 0, right? So this means that you... But don't think about these from a nodes perspective. Think about this from a states perspective. So if you apply a Hadamard gate, and you measure a 0, you know you're in this node. So then effectively, this means that you're not in these nodes, right? Because if you're not in this node, then you're not in this edge. So you're in edge 3. So the fact that you're in edge 3, and this is like a chain connection, right? The fact you're in edge and in edge 3, it means your qubit 1 is either these or these, right? And so if your qubit 1 is 0, it means you're in these. It means that you're in the red edge, the edge 0, which in turn something's off in here. There's something off in here. So this means you're in edge 3. The fact you're in edge 3 it means you're both in edge purple and edge red. Oh. That's more complicated than I thought. I gotta find a better way to explain. I gotta find I think I'm doing something wrong, and I'm thinking whether this is quite complicated to visualize. To be honest, way more than I thought. Because U1. Well, you want to say you have you're in two possible nodes, in two possible states, into the plus or the minus state, right? If you think about Q2, why is it that it's in this state? That's what I don't understand. So if you're in 0, then it means that you're in edge 3. And so if you're not in edge 3, it means that you are if you're in edge 3, it means that you are in edge purple. So it means you're in edge 1 and edge 0, right? So you're in this case like a 1 plus 0. Here's also 0 plus 1, so that's because you're here means you're in E4. It means if you're brown and pink. If you're brown and pink, you're you're brown and pink, so you're in the same. There's something off with the. I'm missing something in here. I'm missing some. I haven't. Maybe I should really just draw it by hand. That should be the best thing to do probably next time, because I've spent already an hour on this. But I think I'm gonna go this way. I think I'm gonna stay at. I'm gonna have qubit edges because that helps me say, okay, qubit 2 is in this mixed state, right? Have I done something wrong here? What have I done wrong? What have I done wrong? So first it's a. So first we are, in this case. Then we are. That's a much better visualization, to be honest. In this case, where we have, you know, so qubit 2 and qubit 1, like we have like the 0 is correlated with 0, the 1 is correlated with 1, and this is just independent and it's in a Hadamard state. Exactly. Exactly. Oh, I know what might be the problem actually. I was right. Actually, if I want step 3 to include this extra Hadamard, there's something happening here that I don't know. Like, so it's a Hadamard. This last Hadamard happens on a qubit with 2 nodes, each on different branches. So if I split this, if I do these, like I'm not sure this is what you get. This is what you end up with. Because essentially, when you're wow. So when you're applying the Hadamard here, oh, how does this change things? That must change things. But it doesn't propagate. It cannot change things, that's the point. But it leaves it like that. So what's the def? Ah, I know. Okay. Yeah. I know. So if I measure a 0, I can be in both I'm actually in both branches. Yeah. Oh God, that's what happens. And the whole thing with the minus is a kickback probably. So if I measure a 0, like I'm literally in both nodes, because I can measure a 0 here and a 0 here. So that really, like, this really has happened in here, this last step, right? Because otherwise you have a 0 and a 1. So I can be in both. So I'm both in E4 and E3. And if I'm both in E4 and E3, it also means that I'm in like E01 and E11. The heck is E1 and E0? I mean all these, these 4 edges as well. Which effectively means that I'm in all possible states here, which is, so I'm in all nodes, which is like still a 0 plus 1. Now, if I measure a 1, then it means that I'm in these 2 branches as well. But now I have this negative sign here, which needs to be accounted for. So this minus is the one that you need to, it somehow propagates, right? That's the point. When you make a measurement, that's kind of the state you have. The thing is, when you make a measurement, you're collapsing these two. So actually the measurement will really be So we will really have to implement that as an operation. That's gonna be big to do. So we're gonna have like a def measure, and we're gonna give it the system in the qubit return not implemented. Because that will basically, what this will do is it will just cap, it will just remove. So now we have a minus that you can't lose. How do I account for that, God? Like that minus, like you want these two to then become just like it means you pick a node. It actually means that you pick a node, right? So, and you can pick both nodes, to be honest. Now, if we pick this node in here, you end up, so you go the path of E3, you go the path of purple and red, and so you go the path of like these. If you pick the other one, you go the path of these two here. But now, well, wait. It's, wait, no, okay. Yeah, if you pick a 1, if you measure a 0, you gotta do nothing because you end up in the right thing, in the right place. But if you pick a 1, no, I'm wrong. I think I'm wrong. Am I wrong? No, I'm not wrong. So that was first was a 0. So first this was a 0. Then we actually in TPS2 we created a superposition, but then we split the superposition. And now in TPS3 we're applying Hadamard to each part of it. Right? Yeah. So we stay with these. Now what does it mean to measure Q0? It means that I don't understand that. So I'm trying to understand, I'm trying to visualize here why you need to do the correction. Like it's obvious if you take, it's a bit more obvious if you take a look at this at the state vector, but here I'm being a bit bothered by the fact that I don't know how to interpret that. So I don't know how to say like, so this would mean that I peak, it means I'm in both nodes if I measure the 1. But I still end up in this case, like with the 0 plus 1. So it's kind of, but I know that if it was a 1, it's because I know that I was in this branch. No, that's also not correct. I won the dem plus state. So the correction should have to do with the fact that these somehow gets moved down here. Because if I pick a 1, I'm either here or here. right? Yeah, exactly. But if I pick a 1, it means like that these go and these go. So I have a -1 and a +1. And those can't, like, I should be able to merge them, but I can't. That's illegal. I think that's the that's the point. That's illegal. So I need to correct that by multiplying the whole thing by -1. But when I do that, I carry that multiplication down all these like correlations down to these two ones, which become negative. And so I gotta correct them with a Control Z after the measurement, because I need to be able. I need to be able to. Uh, oh. That's not phase kickback. That's not phase kickback though. Or is it that the measurement induces a phase kickback? Maybe measurements induce a phase kickback. How could I see this better? How could I see this better? Well, I could see this better by implementing the measurement, and then I think that's correct. I think that's what's happening. So what's happening is, if the measurement would say, okay, or not a measurement, but like a maybe a projection operator or something like that, right? So I would say, let's say, not projection, whatever, like I know, like pos selection. So we select once. This means that that minus, like, with the pos selection, the minus doesn't count so much, but like you would theoretically think that these goes, this part goes, and so you're left with the minus in here and this one, and but you can't marry. Like the thing is, if you measure one, you want these to be just one node. Like it's Q0, it's just one state, right? But if you know, if for you to do that, like you have to get rid of that minus, and the only thing you can do to get rid of the minus is to multiply this through the whole branch. So you multiply this through the E4 branch, which in turn kind of minuses these two Q1 nodes as well, and they minus minus these two Q nodes. They goes to brown and pink. Oh, but it should then minus this 0 and this one. It minuses this 0 and this one. Well, yeah, of course. It minuses the 0 and the 1. Which basically, well, you're... No, I don't know, what is it? What is this telling me? That's... It doesn't minus the ones that I thought it would. I thought it would minus these ones. I didn't know how this measurement should work. That seems to be this. It seems to be the state they should evolve into. But I don't know how to implement that measurement. So I really don't know how to implement that measurement. And I need to, right? If I want to be able to implement that, I need to be able to implement a measurement. And then say, just, just bam, measure. I'll just say measure, like a 1 measurement, like measure a 1, right? So what happens if I measure a 1? How does this, change, right? Complicated. that it's more complicated than I thought. There's definitely, I don't know what's ahead of me.